Who is that guy? What's he holding? Looks like a rock to me.
My name is Tom Moss. I was the guy holding the rock. I'm a geologist. Today we're going to look at some rocks and minerals I've collected and talk a little more about them. Geologists do quite a variety of things. Uh, when I was holding that rock, I was a mining geologist. We look for metals to extract out of the ground. Geologists also explore for oil, for the gasoline in your car. Geologists also work in the environmental field to protect groundwater and other waters. That's what I do for a living now. Interested in rocks becomes a geologist. Some people make a hobby of collecting rocks or minerals or fossils. Sometimes they collect them because they're pretty crystals. Sometimes they collect a variety of colors, or they might collect fossils from a certain time period or certain type of fossil, like fern fossils or clams or crinoids or something like that. You may be wondering what the difference between a rock and a mineral is. Just as the letters make up words, minerals make up rocks. A mineral is a natural solid substance with a distinctive crystal shape found in the Earth's crust. Here in the picture you see the clear quartz crystals. Quartz is a mineral. The pink rock is called granite. It has quartz crystals in it. Minerals have many uses. The part of the pencil that's used for writing is made up of the mineral graphite. Table salt comes from the mineral halite. The mineral quartz, like you see there, is used to make glass. A useful mineral that is removed from the earth and sold for a profit is called ore. Everything around us we use has minerals or rocks involved. Metal in your desk, metal in your car, the petroleum that runs your car, jewelry that we wear, all around us. The roads we drive on have something associated with rocks or minerals. The properties of a mineral result from two things. One's the kind of particles making up the mineral, the other is the way the particles are arranged. Particles in minerals are arranged in certain patterns. The pattern formed by their particles gives minerals a certain crystal shape. The crystal shape of minerals is one property that is used to identify them. Here we see quartz crystals. Quartz crystals can be clear or a variety of other colors such as this purple amethyst. Here we have calcite crystals. Calcite is what makes up limestone. Of course, then it's so fine that you can't see the crystals. The pointy looking one is called dogtooth spar. The other is clear calcite. They also call it optical calcite. If you lay it down and look through it, it gives a double image. Here is a galena crystal. Galena is lead ore. Can you see why you would call it a cubic crystal? It's from what they call the cubic system. This is another crystal from the cubic system. This mineral is known as fluorite. Fluorite is what makes the fluoride that goes in your toothpaste. This mineral is called mica. With mica, the individual crystals are actually very thin sheets. You can actually see through them. And they call a set of mica crystals books. Good property that can be used to identify minerals is their hardness. Hardness tells us how easy it is to scratch a mineral. 10 minerals are used to make up the hardness scale. The minerals are numbered from 1 to 10 according to their hardness. Talc has a hardness of 1 and can easily be scratched by a fingernail. Here's the talc, and watch while I run my thumbnail across it. It's one of the few minerals you can scratch with your thumbnail. Now, a real easy test is to use a penny and a nail and your thumbnail. The penny is a little bit harder than your thumbnail. It will scratch limestone or calcite. like so. Now, the other thing you're going to see in Middle Tennessee is called chert. It goes with the limestone. It's much harder than a penny. All I'll leave is a copper-colored streak from the penny. It's even harder than a nail. It leaves a silver-colored streak from the nail. Now, chert is just like quartz. Quartz is harder than a nail too. But most of what you're going to see here is going to be chert, which a nail won't scratch, and limestone that even a copper penny will scratch. Okay. Minerals can also be identified by their colors. Quartz can come in several colors. You can have clear quartz, or purple quartz, which is amethyst, or a pink quartz that they call rose quartz. And sulfur is always a bright yellow color. It's one of the few. And of course gold is always gold, and silver is always a silver color. Now, this stuff here, this bright goldish shiny stuff, may look like gold. It's actually pyrite. It's iron ore, not gold ore. You've probably seen in some old movies where a miner bites into the gold to see if it's real or not. Well, you can bite into gold with your teeth and dent it. This stuff would break your teeth. It's quite a bit harder. You couldn't scratch it with a nail or cut it with a knife. And of course there's also, this is called azurite. It's a kind of copper ore. That's why it's got the, copper ore typically has kind of a greenish purplish color. They call this peacock ore, and I think you can see why with the play of colors. Another way to identify different minerals is by their luster. That's how the light shines back off of the mineral surface. Some minerals have a metallic luster, like this galena, the lead ore. You can see how shiny it is. Or this peacock ore has a metallic luster. Other minerals have what they call a non-metallic luster, such as this quartz. Notice it's still kind of shiny. Or this sulfur, which has a really dull finish to it. Rocks are made up of various minerals. Rocks are classified into three basic groups by the way they are formed. Igneous, melted rock that hardens, like you see here in this volcano picture. Sedimentary, which means laid down in water and cemented. Or metamorphic, which means a rock changed to another rock by heat and pressure. Some spots inside the earth are so hot that the rock there melts. Melted rock is called magma. Magma that reaches the earth's surface is called lava. Igneous rock is rock formed from melted rock that is cooled and hardened. Magma can form rocks beneath the surface of the earth where the magma has a long enough time to cool and forms crystals you can see. Lava can form igneous rocks on the earth's surface where the lava cools rapidly and there are no visible crystals. Igneous rocks that cool beneath the surface of the earth include granite and gabbro. Here's the pink granite. You can see the actual crystals or grains in the rock. Gabbro is a little finer grain, but again, you can see, if you could see it up close, you'd see grains in the rock where it's had time to cool and have visible crystals. Granite is made up of lighter colored minerals such as quartz, light colored feldspars, and mica. Gabbro is made up of dark colored feldspars and other minerals, and it has no quartz at all, so it's dark. Gabbro and basalt are actually the same thing, but basalt, just like basalt and gabbro have the same makeup, but they look a lot different. They're called a different rock because they're different grain size. So are rhyolite and granite. Rhyolite cooled as a lava and you can't see any crystals at all, and granite cooled from a magma below the surface of the earth and had millions of years to cool, and you can see all the grains in it. Obsidian and pumice also have the same makeup as granite and rhyolite, but yet they cooled even faster. Obsidian cooled so fast that it cooled as a glass. It's a volcanic glass. It will cut you like glass, and it breaks like glass. Pumice had a lot of gas bubbles in it when it was formed, and is very, very light rock. That's what you saw me holding in the very first picture. Pumice is actually so light that it floats in water. Other rocks can be distinguished by how heavy they are as well. But this one is the lightest. Of course, the lead ore, the galena, is heavy in your hand. Sedimentary rocks include shales, sandstones, and limestones. Shales and sandstones are from the erosion of older rocks, which could have been sedimentary, metamorphic, or igneous. Water, wind, and ice break up the old rocks into sediments, and then rivers and streams deposit these sediments into lakes or oceans. The way you can tell sandstone from shale is sandstone has visible grains of quartz in them. Shale is made up of clay, and of course you can't see clay minerals with your naked eye or even under a microscope. Most sedimentary rocks form in layers. The sediments eventually are piled deep enough that they become cemented together into rocks. Shale is made up of clay minerals, and sandstone is made up of quartz grains. Limestones are actually organically grown rocks. Limestones are the result of dead plants and animals such as algae, corals, clams, etc., that have been cemented together through time. Another interesting aspect of sedimentary rocks is that they contain fossils, especially the limestones. We'll look at some of my favorite fossils a little bit later. Another type of sedimentary rock is conglomerate. It's actually gravel-sized rocks or bigger that's cemented together in a kind of a lumpy, concrete-looking mass. Metamorphic rocks are actually sedimentary, igneous, or other metamorphic rocks that have undergone tremendous heat and pressure, but not to the point of melting. The tremendous heat and pressure causes the rocks to recrystallize into other minerals or larger crystals of the same mineral. Metamorphic rocks include slate, which was previously shale, but it was the clay minerals are oriented better so that it forms better layers. They used slates for blackboards from colonial times up through World War II. It's a little harder surface. A shale never grows in that big of pieces, but they could cut a large sheet of slate and use it for a blackboard. Marble was previously limestone that's been recrystallized. They used to use it a lot in buildings, and of course some of the igneous rocks and metamorphic rocks are also used in tombstones, particularly granite. Another metamorphic rock is called gneiss. It's spelled G-N-E-I-S-S, but it's called gneiss. It was previously granite, or a mix of sandstone and shale, that forms this streaked zebra layering. It's a very distinctive metamorphic rock. Some people concentrate on collecting fossils rather than rocks and minerals. Here in Middle Tennessee, you're likely to find corals, such as this coral here, from here in Dixon County, or you're also likely to find crinoids. A lot of people call them Indian money, but these little disc-shaped skeleton pieces of something similar to a sea anemone, and also, of course, brachiopods, which are similar to clams. Other interesting fossils include snail fossils, or some of my favorites are fern fossils. They tend to come out of shales and sandstones. You can also find wood that's been petrified. See the grains in the wood? And if you look at the end of it, you can even see the tree rings. Last but not least of my fossil collection is a dinosaur bone. This bone is about a foot long and came from a duck-billed dinosaur in Canada. It's probably his thigh bone. Also, if you look at another piece of a bone from the same place, you can see what would have been bone marrow. Now, dinosaur bones are no longer bone. They're really rock, but they preserve some of the features of the original bone. So the next time you stub your toe on a rock, you might reach down, pick it up, and take a look. What kind of rock really is it? Is it a limestone? Is it a sandstone? Or some other kind of rock? How did it get there? If you want to learn more about rocks and minerals, you might try some of these books at the public library or buy one at your local bookstore.